Here we will take a look at adding mixed numbers using area models. This standard builds on the work students did in fourth grade, where they added fractions, including mixed numbers, with like denominators. It also requires students to apply what they learned about finding equivalent fractions, since their work in fifth grade will involve fractions with unlike denominators using related fractions. Related fractions are like what you see here with 1/4 and 7/8. They are fractions in which one denominator is a multiple of the other. Students in fifth grade are also expected to use benchmark fractions to assess the reasonableness of answers. Students should have ample experiences using models to build understanding and to allow them to use reasonableness to find a common denominator prior to using the algorithm. So let's look at how we can add 3 and 1/4 plus 1 and 7/8 using area models. Before we begin, we'll estimate. When we look at 3 and 1/4, we know that 1/4 can be a tricky number to estimate using benchmark fractions, since 1/4 is exactly halfway between 0 and 1/2. So it would be hard to determine if this should be just 3 for our estimate, if it should be 3.5. Really, you could go either way with that. You could say 3 and 1/4 is closer to 3. You could say it's closer to 3.5. And also, some people like to just leave 1/4 as it is and say that this is just 3 and 1/4 and work with that as a friendly number for their estimate. So there's really no right or wrong way to do that. For our purposes, I'm just going to leave it as 3 and 1/4. And then I'm going to look at 1 and 7/8. I know that 7/8 is just 1/8 away from a new whole. So that would let me know that 1 and 7/8 is close to 2 wholes. And so that lets me know that our estimated answer will be 5 and 1/4. So I would expect that when I add these two fractions, our answer will be somewhere around 5 and 1/4. I know it will be less than that though, since I'm not really adding 2 wholes to 3 and 1/4. I'm just adding 1 and 7/8 to it. So in order to begin to solve using the area models, I will first model both of these mixed numbers. So let's start with the 3 and 1/4. So I will need to show 3 wholes. And then I'll draw another hole where I'll be able to show the 1/4. So we will have 3 holes, 1, 2, 3. And then this last hole I will split into fourths so that I can show our 1/4. So there we have 3 and 1/4. And to that we are going to add, 1 and 7/8. So I'm going to draw one area model for the hole, and then another one for the 7/8. Now I'll go ahead and shade in the 1 and 7/8. So there's one hole, and then 7/8. 1, 2, 3, 4, 5, 6, 7. So now that I've modeled both 3 and 1/4 and 1 and 7/8, I know I need to look and see with the fractions that I've modeled if I'd be able to divide one of the models into the same number of parts as the other one. So I see here in 1 and 7/8, I have this model split into 8 equal parts. When I look at my model for fourths, I know that I can also split that into 8 equal parts, and then that will allow me to be working with eighths in both of these numbers. So I'm going to do that now. I'm going to split this model here of the 1/4 in half like this. So now this model is split into 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8. So it's now split into eighths. And I can see that there are 2 of those eighths shaded in. So this was 3 and 1/4. And I've just shown that that is equivalent to 3 and 2/8. And now we can add that 3 and 2/8 to this 1 and 7/8 that we have down there. And so when we look at this, some students might like to just draw all of the holes all over again and then add the fractions in an entire new area model. Some may like to work with what you have here already. So I'm going to show how you can use what you've modeled already to help solve. So we have a hole here. So we have 1, 2, 3, 4 holes. And then what we could do here, I see that in this 7/8 down here, if I had just one more eighth shaded in, I would make another hole. So what I'm going to do is basically I'm going to take this eighth that was here, and I'm basically just going to move it right here to go ahead and complete this hole. So I'll shade it in yellow there to show that I'm going to move that eighth down there below. And so now I filled in another hole, so I have 5 holes shaded in. And then when I look back up here at the 3 2/8, remember that I moved this eighth that's circled. So all I have left in this model is this 1/8. And so what I can see then is the answer here is 1, 2, 3, 4, 5. And we can't forget about this eighth. It is 5 1/8. And when I compare this actual answer of 5 1/8 to our estimated answer of 5 1/4, I know it's reasonable since those are both pretty close to each other. I also remember that when we estimated, we said we knew our answer would be close to 5 1/4, but actually a little bit less than that based on how we had estimated the 1 7/8. And I know that 5 1/8 is a little less than 5 1/4. So I know this answer is very reasonable. And this is how we can use area models to add mixed numbers.